the larger the person is, the faster they fall, right? This math I just did seems to say it's independent of the mass, right? So I guess the TV's lying to us. Go figure. Let's see here. So there you go. That's the formula for the acceleration. Like that. Hey, if you wanted to work this problem without friction, what would have been the difference? I mean, you could think about the problem without friction by just setting the mu sub k equal to 0, right? So this says that if you just put a box on an inclined plane and let it slide, if you can neglect the friction, it slides at g sine theta. Okay? So you're like, all right, I'm not enjoying today. This seems like something I don't know yet. I don't know, maybe you had physics in high school though, so this is kind of a review for you. I have done almost nothing three-dimensional today, right? Except talk about 3 dimensions briefly. So there's that. These are all idealizations, right? But we can add an example to this. So I'll make the inclined plane go the other way, like so. And suppose I got a box. I give it initial speed of, I don't know, I guess we haven't done enough of this yet, 30, well, let's say I give it a shove at 10 meters per second down the plane, right? And suppose that this angle here is 30 degrees, yeah? So then my question is, if how to say this? Well, let's make it relatively simple. Let's suppose we know this distance. How far do you want the box to be? How far do you want the box to be up this frictionless plane? What's that? 1,000 meters. I like it. 1,000 meters. So 1,000 meters, right? And if you don't mind, are you guys open to this? Let's call that the x direction, just as a label. Is that going to be confusing to you? Because I know we usually use x direction for horizontal, but if you're willing to, we can say that's a change in x of 1,000 meters, right? So, all right. So I guess my question would be is how much time does it take for the box to reach the bottom of this frictionless plane, given that it has an initial speed of 10 meters per second? It's on the surface of Earth, so gravity's 9.8 meters per second squared, right? Usual thing. And no friction. How do we figure out how much time? So following the analysis we just did over here, and I'll run through it again. No, you know what? I will not run through it again because I don't want to hurry. So the acceleration here is going to be g sine of 30 degrees, yeah? Fine, I'll draw this much. This is mg, right? So the part of the acceleration which we care about is this part right here, right? Did I do that right? Sometimes I cheat. I make my gravity go all the way down so I can see the triangle better. All right, let's look at it. So gravity is like this. There's also this piece, right? Where's this angle 30? Where's 30? In this picture. 30's here. Where else is it? Right there, right? So you can see that the green is the opposite in my current picture, right? To that 30. And so the green is mg sine 30, yeah? So the, Newton's second law says ma is equal to g sine 30. Those are all the horizontal all the forces parallel to the plane acting on the mass, right? The vertical story is not interesting. It just says that the normal force cancels the perpendicular component of gravity. They cancel out and give us zero acceleration perpendicular to the plane. That doesn't really contribute to the motion here since I'm assuming no friction, right? So we just have acceleration, excuse me, of g times sine 30 degrees, also known as 9.8 meters per second squared times what? 0.5, because sine of 30 is 0.5. And so we got 4.9 meters per second squared. Okay, so that's the accelerate. We have a constant acceleration. We have an initial velocity. We have a total, total change in x. How can I figure out the final velocity? What's VF? How about this? VF squared is equal to V naught squared plus 2a change in x. So what's the final velocities? VF is actually the square root, right, of 100 meters squared per second squared plus 2 times 4.9 meters per second squared times change in x, which was 1,000 meters. So that should give me my final velocity. I'm sorry, I keep forgetting to move my demo. Has the roll worked its way around everywhere? Okay. Get that before I forget. Thanks, guys. I'll try to have a quiz Thursday, by the way. I know I need to have more quizzes in here. You're like, no, you don't. But yeah, we should have a quiz Thursday. And I will try to make the quiz actually about Newton's second law because you need to think about it for yourself. It should be exactly like one of the problems I've worked today. Different numbers, but no, change in. Like I'm not going to take an inclined plane and add a pulley and then see what happens, right? That comes later. So, all right, so what is that? Indeed. What would the units be? Let's see here. Looks like I've got a meter squared per second squared under the square root. Yeah? Does that make sense? So my calculator has told me 30 times the square root of 11, which is useless. However, this is, to a good approximation, 99.5 meters per second. Does that answer the question yet? What was the question I asked? I asked, how much time to get to here, right? So we just figured out that the final speed there is 99.5 meters per second. This box is really moving. You don't want to try to stop it if it's got any kind of mass at all. It won't go well for you. How much time? How do we figure that out? What should we use? Hopefully this is the part you already have some kind of mastery of at this point, because we're not to the test yet, but it'll be here before you know it, right? So if you're still struggling with the projectile motion part of this course, you need to kind of, try to work on that. So that's the formula, right? Final velocity is initial velocity plus acceleration times time. I know the final velocity now. I know the acceleration. I know the initial velocity. The only thing I don't know is time. So solve for time. So VF minus V naught divided by A, which is 99.5 meters per second minus 10 meters per second, divided by my acceleration, which was 4.9 meters per second squared. As you can see, the units work out because the meters cancel, and I somehow got, this is interesting. I don't know how this velocity, final velocity, has somehow acquired the units of acceleration in this formula. It's interesting and also wrong. So that should be meters per second. And so whatever that is, see here. So that, yeah, 18.27. So it would take 18.27 seconds. So I hope this gives you some idea about how we do Newton's law. These are pretty standard examples I've looked at today. So I hope it gives you a good start. You know, look at the homework. We'll talk about it next time if you've got questions. Yeah? Thanks, guys. Again, no relative motion on the test, yeah? Yes.